All right, let's go over this last example. So this one is just a critical thinking type of problem. Hint, hint. So the graph of f consisting of three line segments is given above. So g of x is given as the integral from 1 to x of this function here. Okay, so that's how g is defined. So part A, compute g of 4. So we're going to plug 4 in for the x. So we're calculating the area from 1 to 4. So it'll be first of this skinny trapezoid, then the triangle that's above, and the triangle that's below. So for the trapezoid, it's the height, so 1, times the sum of the bases. So the first base would be 4. Second base is 1, all over 2. Plus 1/2 for the triangle. The base is 1, height is 1. And the second triangle, it's below, so it's negative. And its base is 1, and height is also 1. So they cancel each other out, so the answer for that is just 5/2. Okay, g of -2. We're going to plug that in for the x. And if you notice, now the bounds are backwards. So we're going to flip them. And when I flip the bounds, I get a negative that shows up in front of the integral. That's one of those properties we looked at earlier in the chapter. So now I need the area going from -2 to 1. So it's this big triangle up here, but that negative still stays out in front. So the base is 3. The height is 4. So you end up with -6. All right, part B, find the instantaneous rate of change of g with respect to x at x equals 1. Instantaneous rate of change, what is that? Well, we have two types of rates of change. One was the average and one was instantaneous. Instantaneous is really the derivative, so they want the derivative of g. So I'm taking the derivative of g, so I have to take the derivative of that integral. Well, what theorem do you think you can use with this? That's right, the second fundamental theorem of calculus. So the derivative and the definite integral cancel out, and it's just f. So the derivative of g is f. So now I want to evaluate it when x is 1. So g prime of 1 equals f of 1. So f of 1, that's just asking for the y-coordinate. So when x is 1, the y-coordinate is 4. Part C, find the absolute max of g from -2 to 4 and justify your answer. So I got to figure out where there's a relative max. I don't have to worry about a relative min because it's just the absolute max. So you don't worry about any minimums. So I have a relative max at 3. But then I also have to test the endpoints of the interval, the -2 and the 4. So let's test and evaluate the 3. So plug the 3 in. So from 1 to 3, I need the area of that trapezoid again and just that one triangle on top. So the trapezoid was 5/2. The triangle is 1/2. So that gives me a total of 3. Now the other two, I already know those values. I just did them up in part A. So g of 4 is 5/2, and g of -2 is -6. So I'm looking for the absolute max. So which one is the biggest? That guy right there, the 3. So the absolute max at g of 3 is equal to 3. All right, the last part D, the second derivative of g is not defined at x equals 1 and x equals 2, which should make sense. This graph is the first derivative of g, and it's got sharp points here and here. So the second derivative wouldn't exist at this point, and it wouldn't exist at that one. So which of those values are x-coordinates of points of inflection of the graph of g? Justify your answer. So it's going to be this, or this one, or both. Well, it's going to be this one up here when x is equal to 1. And how do I know that? Well, that's because that's where this graph, the derivative of g, has an extrema. There's no relative max or relative min here, so it can't be an inflection point. So x equals 1, since f has a relative extrema at x equals 1. Another way to look at it too, the slope of this is positive, the slope on the other side is negative. It switched from positive to negative. That's how you get an inflection point. It has to switch in sign. Here, slope was negative, this slope was also negative. It didn't change. So the second derivative switches in sign from positive to negative at x equals 1. So that gives you a point of inflection. All right, that is the last video for new material for Math 400. So let me know if you have any questions. Just send me an email, Zoom during office hours, and just give these a shot. So hope you guys enjoyed the class, and yeah, we'll talk to you later.